Hello everyone and welcome to today's Siemens Xcelerator webinar. Revolutionizing water infrastructure inspections, smarter, safer and easier with drones and AI. My name is Stefan Ehrlich, I'm Ecosystem Success Manager for the Xcelerator Marketplace. And with me we have Camilo Gaviria from Aerosophia, co-founder and CTO.
Thank you, Stefan, for having us. Looking forward to our discussion today.
We have Sebastian Guckelberger, Head of Market Development for the Water and Wastewater vertical at Siemens.
Great to be here.
And Jeroen Hannekamp, CEO and co-founder for Aerosophia.
Thank you, very excited.
So, before we start things off, quick housekeeping rules. This session is going to be recorded, so if you have any questions, put it in the chat, we will answer it, and at the end we'll also have a quick Q&A session with everybody. So, we're talking water vertical and water infrastructure. What are the main challenges the water vertical is facing at the moment? Sebastian, from Siemens' perspective, could you give us some insights?
We are in really what I would call a perfect storm at the moment in the water sector. On the one hand, access to clean water and sanitation is a human right, and various industries are relying on secure water supply for their production. On the other hand, various different aspects come together. Think of climate change with increasing droughts or many heavy rain events. Think of aging infrastructure and underfunding of the infrastructure. Think of aging workforce and a gap of skilled workforce. And all these elements put stress on our water systems. So the water sector is in real need for a more sustainable, more efficient and more resilient approach to operate our water infrastructure. And as a leader for automation, electrification and digitalization, we are helping our customers and partners to achieve that.
So you touched upon those challenges are really stressing the operations of those water infrastructures. Do you have a few examples on how those challenges really impact the day-to-day operations, the life of the operators for those plants?
Sure, could talk quite long about this now, but these are challenges affecting the operations in multiple facets. So thinking about meeting stricter regulations, for example, to leakage rates on non-revenue water, think of ensuring resilient and optimized water treatment processes to reduce costs, or think about ensuring the uptime and avoid failing assets to ensure the water supply. These are just some examples of how these challenges affect the day-to-day operations. And I think one concrete example to make this really tangible is non-revenue water. So non-revenue water remains a top 3 challenge for all utilities around the globe. We are losing roughly 30% of the water in the water distribution networks. And in the past, this was mainly approached through manual inspections, where people with hydrophones are going through the city to monitor and detect leakages in the city network. Today, technology can help with AI-powered solutions to monitor, detect and pre-localize leakages, also smaller ones and bigger ones, to not only avoid financial and resource losses, but also to free up the time of the workforce to tackle these challenges and to avoid consequential damages. And we as Siemens are looking at that from an integrated water management perspective. So bringing these different value-add functionalities like non-revenue water optimization, energy optimization, process optimization into the control center for integrated water management. And this doesn't include only the Siemens solutions, but also third-party solutions. And by the way, just talking about the non-revenue water example, there are different technologies that can help to address this challenge, be it based on field data, be it acoustic, be it flow, but also drone data that help to address this challenge. And by the way, this is also not in a competition against each other, but they are nicely complementing each other to ultimately achieve the goal to reduce the non-revenue water rate.
perfect handover, I'd say, to Jeroen. Maybe you could give us some insights on how Aerosophia views those challenges that Sebastian has touched upon.
Yeah, very much. I mean, I really like your story. And in this respect, we were born in pipeline inspections with our solutions. And with that pipeline inspections with Aerosophia, we actually went to one of the water authorities in the Netherlands to start with some time back. And we said, hey guys, can we support you with pipeline inspections? And then they actually said, yes, great idea, but there is one higher urgency, which is the dike inspections component. And actually, as per your points, because I hear them all on a daily basis independently during the different clients we work with, aging people, as a result of which there's less dike inspectors here, but also the global warming, as a result of which the sea level rises. Sea level rises means your dikes become more and more relevant in order to protect the country. And you know, in the Netherlands, we're based in the Netherlands, that's quite of a big issue, of course. So we got the question, how can you support us with dike inspections? Because to date, they are actually using 4 hours per kilometer dike to inspect. Imagine that there's thousands and thousands of kilometers of dike to inspect in the Netherlands. It's not just the dikes on the sea side, which in a small country like the Netherlands is relatively overseeable. But it's also the dikes on the riverbanks, the canals, the waterways. There's literally tens of thousands of kilometers of dike to inspect. And if you take 4 hours per kilometer dike to inspect, and by then you don't even know whether you've inspected the full dike, because imagine that someone walks on the left side of a dike, a steep dike, right? Someone walks on the left side of a dike, needs to go back, needs to jump a ditch or climb a fence, needs to walk back on the upside. Imagine that there's even animals there, like bulls, sheep, whatever. Needs to walk back on the right side of the dike, has to see it. And at that stage, it takes a lot of time. And by the way, if then the inspector finds something, what is he going to do? Is he going to make a picture with his device of that specific component, writing down where it is? Maybe a little bit more sophisticated, but just to kind of exaggerate to make my story in this case, this can be made much, much more efficient. And that's what we've started to work with one of those water authorities, and now ramping up with a lot of water authorities to see how can we use drones and AI in order to make those inspections way more efficient. We fly 5 meters per second instead of 4 hours per kilometer. We capture the full dike instead of only the components in which an inspector looked at that stage. So in this case, making that way more efficient is what we've done, and exactly actually covering all the topics you raised as key issues in water management.
Perfect, thank you, Jeroen. So also perfect handover to your co-founder and CTO for Aerosophia. Camilo, what role does AI play in the solution with drones and the counterplay with what Siemens is offering?
It's a very good question. It's actually a question that triggers a years-long discussion, which is, what is the value of AI? And it has a very concrete use case in what we're doing in water management. Water management, in my view, is one of the most underrated and underappreciated disciplines, let's call it, existing out there. Even from Roman times, maintaining aqueducts was a humongous task. The Roman emperors spent legions protecting them, maintaining them, and the first thing that they would do is creating them when they conquered a new city. So it just exemplifies the level of human complexity required to keep them operating. So what does AI do for that? Well, it removes that complexity. Our view is it should remove that complexity from the main job of the human being, and it should make it an accessory, a tool, just a supportive piece of data to make what humans do best, decisions, or what we should do best. So ultimately, that's the approach we took in Aerosophia. We took the approach of using the best of the best, commonly, readily available AIs. We believe in an open AI paradigm where open source is the way of working, where we build on the knowledge of others and we give our knowledge for others to build up on. And it provides a systematic way of capturing in a smart, really smart fashion, all the potential issues that a water management system could have. If you imagine what Jeroen was saying, we have thousands of kilometers of dikes and high pressure pipes. At some point, the paradigm of AI shifts from finding every single leak with 100% accuracy to find every potential risk and let us decide which ones to pay attention to based on data. The reason for it is, still today, it's nearly impossible to state that an AI will predict with 100% accuracy the location, intensity, severity of any individual issue, crack, leakage, erosion, you call it. But what AI can do very well is scrub through millions of pictures, thousands of point clouds. I don't know how many terabytes of data you're gathering from the flow sensors in the individual pipes. And with the help of AI on the data side, with the help of AI on the drone imagery, computer vision, what we do best is surface the risk items, the risk points, in a very visual way, such that the analysts, the people that are responsible for making the decisions, have in a central cockpit just the right amount of information to ensure that their asset, their pipeline, their plant is operating under nominal conditions. That also enables in the long term, and when you pair technologies like the Siemens technology and ours, to add layers of different types of sensory information over time. So now we're no longer talking about what we did yesterday or what Aerosophia can do today or what the sensors can do on the hourly basis. We're able to go back in time and do very interesting assessments like mixing geographical information with actual sensor information over time and say, okay, which sites, which dikes, which areas are more prone to issues, were prone to risks given their context, the usage of the waterways, the amount of traffic that passes over a pipe. So the technologies are there to simplify. That is the role of AI in the context of water management. Simplify and enhance or highlight.
Where Camillo makes an extremely important statement as well, the expert or the analyst is extremely important. We're not here to replace the human expert. We are supporting the human expert to make the decisions on the data which we provide them with in order to really focus on the core of where the expert is good in.
And it goes down to experience. And maybe you've seen this in some other areas of water management, but one of the typical behaviors we see is we meet with an expert inspector. We go to a dike and we see the dike, and I see an erosion patch, a crack, and I say, oh, I take note. Oh, very worried, there's erosion there. And I see the inspector pass by. Okay, no, apparently this wasn't that important at all. And then 10 meters later, there's a small disbalance in the terrain, perfectly covered by grass. Nobody would have stopped for that deformation. And this guy is just taking pictures, measuring, has really a puzzled look in his face. Well, it turns out that in his experience, that erosion patch is the result of a strong summer. It's been there, by the way, every summer for the last 10 years, so not an issue. That little recession is an early indicator of water going through the sand or the peat core of the dike. That is something that AI by itself would have not picked. Why? Because we have no mechanism to see through ground yet. The computer AI will not do anything for that. And that's where the experience of our inspectors kicks in. That's why we do not aim for replacing with AI any individual discipline. We aim at complementing them, enhancing them, and unburdening them from the data that is not theirs to make decisions upon. We pre-process it and we give them the facts that they need to make the right choices. But they are still the experts. And it's very difficult, and it will still be, in my view, very difficult to capitalize entirely that expertise from an AI perspective. Someday, maybe, but still, we focus on providing help.
And you said, indeed, in this case, which I fully agree to, we're relying on the expert in this case. We're closely collaborating even with the individual experts of our clients. Why? Because some issue in an erosion on a specific dike in the northern part of the Netherlands may be totally different from that one in the southern part of the Netherlands, simply because of the different material the dike is constructed of, the different risk profile. So in this case, we allow the expert to have the right tools in order to be sure that he's seen all dikes, and in that case, makes his own assessment to see what he wants to do with that.
Very good. Thank you. Great insights into how you guys are leveraging AI at Aerosophia. So I'd like to lead over back to Sebastian. So what's Siemens' role in this whole play with data in the water industries? We heard Aerosophia has the focus, they're working with drones. Where's Siemens' strength in the industry?
Yeah, I can only second that. So we are in a urgent need for technology to make the water sector more efficient, more resilient, but also more sustainable. And we can basically build there on long experience in the water sector as a leader for electrification, automation, and digitalization. And we also bring quite a comprehensive solution for condition monitoring, asset management across the entire, how we call it, tech stack, so from the field level to a more enterprise level. So let me just share some examples, starting more on the ground level, on an asset and field device level. Imagine there that you have like a AI-powered co-pilot that helps you to move from a existing, more reactive condition monitoring and maintenance approach to a real predictive and preventive maintenance approach, for example, for rotating equipment in pumping stations or for pumps in water plants. Another example, using smart digital solutions for more seamless operations of and maintenance of field devices and instruments. But then now going also up, as mentioned, these things need to be integrated, these solutions, going now up more on an enterprise level. Our enterprise asset management solutions help then also to make the data-based decisions on operational basis, so where to schedule and what maintenance tasks need to be performed on a short notice, but then also using this data for the predictive part. How do you spend your scarce capital and do the right investments to ensure that the water infrastructure remains resilient and efficient in a good manner? And Aerosophia is basically complementing this approach from Siemens side, where we are more focusing on the assets, very nicely with regard to the civil infrastructure, if we are looking at dikes, embankments, and so forth. And with these combined solutions, we can actually provide a 360-degree view, I would say now, to our customers to keep their infrastructure up and running.
It's actually very interesting because this use case that you just mentioned around Siemens taking care of the data part around the assets, but also the enterprise layer, is something that we've seen in the past, and how it was very colorfully placed by the customer we were working with is Aerosophia provides yet another input to the platform for water management that Siemens has, and what we can do that complements the entire picture is we provide the aerial imagery, we reproduce the point clouds, and then we can build the assets that reflect the dike. And what they found very interesting is that the operational detection of potential issues, not even existing issues, because those existing issues would have already been recorded in the asset management system and in the predictive maintenance system. But with aerial inspection, there were areas of risk that they were able to identify. And by providing a multi-layer analysis into the risk profiles of a particular area, they were able to flag a particular asset as being at risk, even though the data from the asset itself, and it was the maintenance data didn't point at anything, the context of the area where it was had, for example, vehicle tracks on top of a site where a high-pressure pipe was going. The presence of those vehicle tracks is not available through any of the sensors because it was one time that passed. But from a context perspective, it adds to the asset maintenance, asset management, because now they know that they need to deal with the risk of vehicles passing through a particular track. So it's absolutely beautiful to see how the technologies complement to add into the process of maintaining and supervising how different civil assets are being used and maintained.
Yeah, I like it. Just to make it very clear with an example, indeed, you spoke about the vehicle tracks. So for one of our clients, we're actually flying on tracks of high-pressure pipes. And indeed, then you have a couple of events, right? You have palliative events and you have preventive events. Palliative events are things which seemingly there is a leakage in the pipe already, as a result of which there is stuff happening, which we can detect. Think growth of specific flowers, think water which is floating up to the ground, things which we can actually detect. Typically, with the sensors you have, you can also detect that, but it's kind of a double-edged sword. We know exactly where it is, and we can combine that. But indeed, as Camillo indicated, we had issues that a big tractor, right? So a big truck able to, for agricultural purposes, actually was driving consistently on the same place to enter the land. And that same place, actually, because of the weight of the truck, was pretty much depressed at that stage. And as a result, it would almost hit the pressure pipe. And in that case, just a call to that specific farmer to say, hey, you know that there's actually a pressure pipe below your ground, please enter through a different direction, saved a lot of work for correcting and fixing effectively the leakage in the pipe, which would have been caused in case that truck would have kept on driving that way. And that is just the same with construction sites, right? We fly over specific tracks, there's a construction site which starts, and in that case, just the fact that that starts to happen and that someone may actually dig in the ground in order to see whether there's something, in order to build something, is already an indicator to say, hey, let's have a call, let's have a chat, let's send an inspector, because there is a high pressure pipe below.
Great example of the collaboration potential here and why even Siemens and Aerosophia are partnering up as part of the Siemens Xcelerator ecosystem. I'd like to hear Sebastian to talk a bit about the story, because it sounds to me like a perfect match that we have Siemens being at the heart of the plants in all the machines with the sensors, and then if you need some to track the outside influences with some dynamic measures like with drones, it feels like a perfect match made in heaven. So could you tell us a bit about that?
Yeah, sure. So I truly believe that nobody can do it alone or should do it alone. So this is really an ecosystem approach that we need to tackle these challenges in water and wastewater. And I think Siemens Xcelerator is a great example how we strengthen this collaboration, but also bring it then to the market. And we are from Siemens supporting there from basically three aspects. First, we provide on our own off-the-shelf solutions that help the water sector to become more sustainable, more efficient, more resilient. Think of simulation software for real-time optimization of sewage treatment plants. Think of AI solutions for preventing sewer overflows. On the second element, we are also providing, as a technology company, basically the digital tools and the infrastructure to develop powerful industry-specific solutions. Here we are talking about platforms like our low-code development platform, or our industrial AI suite, or advanced analytics capabilities that can be used from our partners, from our customers, to develop their very own solutions. And third, and I think this is the most important part, is then Siemens Xcelerator as like an open digital business platform that actually brings all these elements together, be it Siemens products and solutions, be it third-party and partner solutions, and make this really accessible to the water and wastewater sector, because these solutions are powerful and can help the water utilities to tackle their most pressing challenges.
Perfect description of the Xcelerator vision. Essentially bring together best-in-class partners to work together at customers to solve real-life problems. So we heard a lot about the Aerosophia solution. I'm very curious to see the demo. Before that, I'm curious though, we heard low-code platform, we heard Mendix. I've heard rumors that you guys are also using Mendix within your solution. Will you touch upon this during the demo, or do you want to give a few sentences prior to that?
Yeah, we use Mendix as the knitting fabric on how to get Aerosophia to collaborate and integrate nicely with the other Siemens solutions, specifically with asset management and maintenance. The power of low-code is that it allows us to align and intertwine business processes that may have originally been conceived as slightly separate or disjoint, and allows you to build a customer-centric version of those two that intertwines, thus ensuring that data seamlessly moves from one domain to the other. This was, in my view, a very smart move from Siemens, adding this technology to the portfolio, because it allows us to literally, data-wise, seamlessly integrate, for example, the detections that we do, send them through Mendix, aggregate them, and add human intelligence through a Mendix UI, to then pair it up with whatever decision support has been made by the analytics in Siemens, but still keeping the user as a centric key component of the process. We in Aerosophia use the concept of human in the loop. It's very common in AI. We like to drive AI by having humans in the loop. From a broader process perspective, we also believe that, in this case, Mendix allows to keep the human in the loop of the business process of receiving detections, understanding what they mean, complementing their data and the context with, for example, predictive maintenance events or suggested maintenance schedules, and then ultimately build a work package or a work order that comprises all the required pieces of information. And as you said, there's no one single company or person who knows it all and should do it all. So this Mendix technology allows to bring all of the people that collaborate together in a single ecosystem, and that's pretty powerful.
And I think actually in this case, it's about the customer, right? So UX, UI, user interaction is absolutely critical in this case. In this case, if specific clients, water authorities, provinces, municipalities, clients have a specific process in place, we're not here to replace that process, we're here to support that process. So how can we make sure that all the footage, call it drone data, camera data, sensor data, whatever, is being captured, is being analyzed through a workflow which is recognized by and makes sense from a customer's perspective, and then flow it actually in their action tools, which are also quite often already existing in this case. And that is why indeed Mendix is the perfect component in order to kind of glue that all together. So that's why it makes a total sense, and indeed fully resonating with Camilo's statement that it makes total sense also from Siemens to have acquired this as some leads.
Very glad to hear that we don't only collaborate on a joint go-to-market with complementary solutions, but that as we as Siemens are also able to provide you guys with technology to help you build your own solutions which complement our offerings. So now with all the introduction, I think it's time for Jeroen to give us a demo on the Aerosophia solution, which I'm really looking forward to.
Same here. Thanks very much. Perfect. So this is the Aerosophia solution as we put it on the Xcelerator portal. And I'd like to tell you a little bit about one of our clients. I'm just using an actual use case of one of the water authorities we work for. In this case, it's Waterschap Hunze en Aas from the north side of the Netherlands. And we offered them the platform, they're using that. And in this case, I'm going to show you just how we do that. You start with a web version. In this case, it's their version. You just log in and you log in on the Aerosophia platform, in which case you see this. And again, as also Camilo already indicated, this is going to be an extremely user-friendly platform where there's a big map where actually everything happens. There's a few components which are relevant here. First of all, you have the projects. The projects are relevant because we structure the Aerosophia use throughout the organization. So you have projects like spring inspection, autumn inspection, inspection for invasive plants. You can make it up to your own projects. Then we have the areas, and the areas I'll explain in a bit, but areas are crafted, are designed in the platform, and based on the areas you determine what you actually want to find out. So the algorithms are allocated to an area. Then you have the analysis on the map. We'll get back there to that in a bit. The analysis on the map will indicate what you can see and how you can work with that. And then you have the manage event sections. So events will be listed, and you can, as an inspector, as an expert, as an analyst, go through them and start working with that. So we're going to start with creating an area in order to inspect. So I'm going to go back to the map, and I'm going to actually first look whether I can even fly, right? So I'm going to look at where I want to fly. I'm going to go to the map. I'm going to go to the upper side of this right now. And I'm going to check the air traffic restrictions. In this case, I'm going to put them on the map. This is all live feed. So in this case, these are the restrictions around the airports in the Netherlands. Well, I want to fly in the northern side of the Netherlands. It's okay if I'm not entering the purple space. And let's find a nice dike here. And let's draw, in this case, the area. So I'm going to draw the area right now like this. And this is what I want to have inspected. Let's call this Stadskanaal in this case, because it's very close to it. And we're there. So saving the area, and this is the area. In this area right now, I'm going to assign algorithms and I'm going to upload the flights. So then in this case, the area will be relevant. Of course, this is now drawn manually, as you've just seen. But what we typically see with larger clients, including the water authorities, they have KML files. So actually GIS files, which they can just upload and which they can use in this respect. So uploading the files will already create their entire dike portfolio, as you will, into the platform, which is 300, 400, 700 kilometers of dike per water authority already. Now, what we're going to do then is actually fly the drone. And this is how it looks like, right? So what I indicated before, 4 hours per kilometer. You'll see right now that a drone flies 5 meters per second. In this case, it's a nice dike where, well, you see that you need to actually jump a fence, cross a ditch. There's no sheep on this one, I think, but it's of course something which you want to avoid if you want to walk there. And also in this case, it's a pretty steep dike. You have to first walk on the left side, walk back on the upside, walk again the other way on the right side, and then walk back. So easily for this 2 kilometers of dike, you spend like 4 hours per kilometer in this case. We do this in 5 meters per second. And again, this is a very nice drone image, but for this presentation, great, but totally useless for inspection purposes. So what we've done actually is fly the same drone, but then with the right camera settings in this case. And what you will then see, again, 5 meters per second, 65 meters, I think, you'll see that the entire dike is captured at once. And this is creating a high resolution recording. For 2 kilometers of dike, we roughly have 1,500 pictures, high-resolution pictures, which we capture in this dike. You connect the drone. To the platform, and then you start to upload your flights. I will not show how the flights are going to be, how the pictures are going to be uploaded. I trust that everyone can do it themselves. But let's take right now one of the flights which were uploaded already. So let me get back to the area in which we were just there. Analysis on the map. I'm going to go here. You see the area. Let me take street view. You see the area. In this case, it's the area of the dike we just flew. And I'm going to check whether the flight is already being uploaded. Now, I'm going to do that right away. So in this case, dike inspections, and you'll see that there is a flight indeed. And you see that on the green lines capturing the entire area. I'm going to add the layer, and I'm going to talk you through what we're seeing here. So yeah, spoiler, you see already detections. I'm going to remove them right now for the story. Removing it here. And I'm going to remove the images of the dike so that you can have the story in this case. So you see, the area was there, and the first thing which we always do is to see whether the drone actually flew over the right area. And you see that with the green lines, that's the actual track the drone flew, and in this case, that's pretty spot on. What I'm always going to do as well is to check whether the drone actually captured all the pictures. And in this case, you see that there's around 600 pictures taken, I believe. And in this case, you see that actually the entire flight has pictures, which means that there was no lack of connection or something like that. It's fully covered. Now, let's then go back to the actual recording. And then you see that all the pictures are being stitched together in an orthotiff, and you have a very high resolution image of your entire dike. In this case, the 2 kilometers, you see our pilot standing there, or actually the pilot of the water authority. And you can zoom in on leaf level as you just saw. And the first thing is, this is human in the loop as well. A dike inspector, an analyst, an expert can now scroll through the entire dike just to apply his or her expertise to see whether there's any issues. And in this case, what you do in this case is just looking at that, and independent of the detections, we're going to see whether there's something wrong. You also have a couple of layers. You have the digital service map and the digital terrain map. And we subtract data from the images in order to see the differences in height, which can also be a sign that something is not right or something needs to be fixed. For example, here you see that there is some sort of a crossroad apparently there. Let's look at the picture again. What is that? Yes, indeed, it's a path. Not sure whether it's relevant for this inspection, but an expert could know, hey, there's something I want to do with it. And specifically when the grass is there, you may not see it with the bare eye, but our digital terrain map and digital service map will find out. What's also relevant is that you can remove the trees and the cars or the objects so that you can actually look at the true surface of the dike in total. Another component we have is the erosion per square meter, or the VARI index as we call it. And in this case, we apply this algorithm and we can show whether the plants are healthy, so you will, in order to see whether there's any dry pieces which can actually cause erosion. Our algorithms trigger on that as well, and they will then show you what's wrong there in that case. So first, manual inspections and looking at that. Now we're going to go to the AI inspections, because we trained many algorithms. It's modular based, by the way, so we can add every algorithm you may already have or you develop yourself. And you see a full list of scheur, which is crack in Dutch, but you see erosions, you see plants, overgrowth, everything which we can do. Let's take one of those topics. So let's go, I think there's a clear one, tracks. Yeah, so we're going to go to the tracks. This is detected. Let's open it. And if you click on it, you actually see it on the platform. And as an analyst, as an expert, as a human in the loop, you can click on it and you can actually zoom in extremely high level. Again, leaf level. You can find your wedding ring if it would have been lost here. And you can actually see whether that's something you, as an expert, as an analyst, as an inspector, want to solve. Again, zooming in on the leaves just to see that you can even detect the species of plant. And again, we can train algorithms for that as well, which we've done for this company. And in this case, it triggers on tracks. And it states tracks. This is apparently something which that water authority wants to see. And you can click on accept or reject the issue. I just clicked on accept. And by clicking on accept, it means that the issue becomes a report which I can assign, open or close. Now let's put this let's have a quick look here. You can see actually a couple of things for creating that report. And this is also what we indicated before, which we can flow into a CMMS, into a system which is responsible for putting the work orders in place for a specific organization. So this is the detections. Or this is the list of detections. And as such, you can, on the one hand, as a human, look through it and see whether there's anything which is not correct at the specific location you're inspecting, whether it's a track of high-pressure pipes, whether it's a dike, whether it's a waterway, a canal, a riverbank, whatever, you can see it. And in addition to that, we have supporting AI, which can already point you towards relevant events. You can tweak the probabilities of the AI to say, let me see everything which is determined 70% chances of being a crack or more. You can play with that in order to make it fit for your specific use case. Now, the beauty of flying the dike is that our algorithms and our technology also allows for creating a digital twin of a dike. In this case, this is the dike you just saw, and let me go into the details. You saw the same dike. Let's go to a couple of events here. So what I indicated before, there is cracks. Let me scroll through a crack right now. Here, there's a crack. You can even zoom in. Well, let's not do it now, but you see it's an asphalt crack. Whether someone wants to do it or not, human in the loop, decision, reject or accept. This is erosion. And let me find if there's any depression here, because that's more relevant. A depression, found one here. This is a depression which is highlighted by the Aerosophia platform. Now, the fact that there's a depression is already relevant. You know whether there's a depression, but it's even more relevant when we can actually go through it. So let me go to the point cloud viewer, and that's here. And you see actually the depression here, and let me see if I can get a little closer to it. You see the depression on the 3D model of the specific dike. Please allow me to change the image to what I want to see. Because the beauty of having this here, and let me zoom in like this, is that you can actually go through it and start measuring. So in this case, the depression, which was on a threshold of 1 meter 20 or more, so depressions of 1 meter 20 depth or more will be detected in this case. And again, this is something which you can put any variables. Let me measure it right now. I have an ability to just draw lines here, and actually I can measure right now that this depression is 16 square meters. And I can also see, if I measure how deep it is, that it's 1 meter and 21 centimeters. So indeed, this is correctly detected by AI, and as such, we can actually calculate not just that there is a depression, but also how much concrete or sand or material the inspector needs to tell through the CMMS that the construction worker has to bring in order to fill the gap. Now the beauty is, you scroll as an expert through the dike and you actually see that there's another depression. There's a depression a little bit more to the right side of it. And let me zoom in here. You see that the depression is here. So it didn't fall the threshold of 1 meter 20. Well, let's measure that in a bit. But actually you see that it's something which, independent of not following within the threshold as determined by that specific water authority, maybe makes sense to fix. Perfect. Now, let's measure it indeed, 1 meter 17, so indeed, correctly so, didn't fall within the threshold of AI, but this specific expert wants to fix it. He adds the event, which means that as of now, it follows the event list in the platform, so it becomes something which will then be taken up in the list. It geolocates the issue in accordance with a map. I'm able to fill and to populate the report specifically, and as such, I can actually state, in this case, depression needs to be fixed, and I can measure it, how much concrete, sand, or material I need in order to do so. By doing that, I'm actually creating events manually just by scrolling through a dike where normally someone had to go. And in addition to that, and that's also the point I wanted to make, and you see right now, it's shown actually beautifully as a spot on the map. And this is one of the big advantages. So say that one of the inspectors who was walking there had indeed fixed that one depression. Right now the inspector, oh, by the way, just to see that with the DSM, the digital service map, I can actually see that it's here. But in addition to just the ability to look at that one detected depression, you have the ability as an analyst to actually review your entire asset, your dike, your persleiding tracé, in order to see that there is something to fix. This is going to be put into a workflow, and the events are listed right now in this case. I think there is like around 400 events which are detected along the dikes of, in this case, specific customer. And what the analyst typically does is just to go through these events. What I just shown on the map is beautiful and something which an analyst and expert can do every time. But in this case, what we try to do is make it as simple as possible. So an inspector just goes through the lists and is able to say yes or no to a specific issue, can click on the thumbnail in order to get the high resolution issue, and then can just put it back in the workflow of the organization. Again, connected through a Mendix connection or directly into the CMMS, as a result of which that follows the standard procedure, the standard process of what a client wants to solve. That means that the workflow has a couple of things. One, it provides the type of detection, whether AI detected it or whether it was a manual detection, for example. A manual detection may have a higher urgency because in that case, the expert, the human said, hey, this depression needs to be fixed, this crack needs to be fixed, or multi-temporal. And multi-temporal means that if you make this part of your process and you fly a drone not once, but on a frequent basis, every month, every year, every quarter, just like water authorities typically do from an inspection perspective, you can actually teach AI to find out whether something changed during the course of those flights. So say that a crack first was 1 meter wide, and the second flight a year later, it turns out that the crack is 120 centimeters. It grew with 20 centimeters. In that case, that may be a trigger event for you as an inspector to do something with that. Per issue, there's a report. The report states obviously the status, what it is, the audit trail, what did this look like the previous time you were here, if of course there, the coordinates, the exact coordinates of where the issue lays, and the risk analysis. You as an analyst put a risk analysis yourself, so if you say every crack larger than a meter is high risk, then we put it high risk. It's going to be put in a report. On the right side you see a standard PDF format in this case. Again, this is to be constructed totally into the format and the usability of a client specifically. As such, it can be assigned, annotated, or closed by using a CMMS. Again, you see the connection of Mendix or Brightly, which is also a Siemens CMMS in this case, but we connect actually with every specific CMMS. Then the status, open, detected, notification sent, in progress, or completed. And as such, you have actually the full workflow of a dike inspection or a pipeline inspection in place through our platform.
Okay, welcome back, Jeroen. Thank you very much for the presentation. Great insights into your solution. One thing I had to think about, though, you touched upon the flight regulations, and drones in general are getting kind of a bad rap at the moment by ending up in places they shouldn't be and so on. So how do you guys face it?
Yeah, that's a very good question, and we were actually laughing about that this morning, right, Camilla? You had a fantastic response to this.
Yeah, well, I see it in a very simple way. 100 years ago, cars appeared. And you can do any type of thing with a car. Give a car to the wrong person and you can do a lot of damage. But if you regulate it, if you establish the rules, if you get your licenses, your courses, then you have a system that operates in the benefit of, well, society. Drones are no different. Yes, they're new. We're still here in Europe, in America, in every place in the world. We're trying to figure out what are the rules that are required to govern the operation of these devices that bring risks on one side, and that's what everybody perceives, but that's our human nature. We're afraid of things. We were afraid of thunder until maybe 100 years ago because we didn't understand what it was. So yes, we're afraid of drones, and we see it on our daily lives. People, oh, there's a drone. It's scary. But two things. First, it will become more prevalent, so the more you see them, the less people react. Second, regulation is starting to catch up and in some cases be quite sensible and fit for purpose, which will also give confidence to society that when you see a drone, well, somebody must know what it's doing there. Today, we're still at a stage where you assume, well, maybe somebody knows who is there, but there's still that feeling of, is this under control? So yes, lots of bad reputation. I think it's not very different from the reputation that cars had 100 years ago when traffic lights didn't exist and well, accidents happen.
And actually in this respect as well, right? So what we typically do, or typically what we always do is before doing an inspection, and actually it's the water authorities themselves doing the inspections, right? We have the platform and we can support with flying, but in the end, even though we're qualified, we will not do the flying itself. Then you register your flight at the air traffic control, which is the standard procedure for these type of drone flights. You sometimes even inform the municipality or the city that there's going to be inspections in that case, and you make it a collaborative approach. And in that case, always easy to answer questions if people sometimes, and most often very excited, right? They're actually not angry or afraid. They're just coming to you guys and say, hey, wait, what are you doing there? And wow, can I see it? That's more kind of the challenge we deal with than people who are really afraid of this.
It's curiosity and fear. If we inform them up front, they know what's happening, and as such, all of a sudden, it's an object of curiosity and no longer an object of fear. So I think that's a very key point. You always need to maintain this constant communication with the people you're servicing. Ultimately, it's the same story that the water management institutions have. You have a huge plant that probably some neighbors may not like being there, but once they understand why it's there and that it's absolutely required for them to be able to live where they live, it becomes part of the society, part of the ecosystem. And I think that with drones is going to be very similar.
And I think there's an additional nice angle to your anecdote with transitioning from horses to cars, because there's also a famous saying, right, with the faster horses instead of cars. And I think this is what innovation is all about. And I think technology is not longer the issue. The question is like, how do we integrate this technology in the processes with a nice user interface and the usability for the operators to make their life easier and work on the important things in the water and wastewater sector.
Absolutely
I think it's a great example.
I think perfect wrap up for the session. Like, couldn't end it better. Thank you everybody for watching. If you have any questions and you have additional inquiries for Aerosophia or Siemens, you have the contacts in the webinar sign up, as well as you can find the offering we saw before on the Siemens Xcelerator marketplace, where your requests will be directly routed to the Aerosophia partners. And yeah, we wish you all the best and thanks for joining us.
Thank you.
Perfect. Thank you.